Hi everybody. Today's lesson is going to continue our focus on simplifying rational expressions. This time we're going to take it up another level. So today I'm going to be going through examples on how to factor and simplify rational expressions and finding those functions' excluded values. So let's start with our first example. All right. So our first example is the ratio of two quadratic equations. So we're going to have to factor both the numerator and the denominator before we can simplify this rational expression. So I'll go ahead and start with our numerator here. Our numerator is v squared minus 13v plus 40. So I have to think of two factors of 40 that will add up to negative 13. So our numerator is going to factor to v minus 8 times v minus 5. Now our denominator is going to take a couple of different things to do here. So first, I notice that all three of my terms here can be divided by 6. So I'm going to factor out a 6 first. And what I'll have left after factoring out a 6 is going to be v squared minus 5v, and 144 divided by 6 minus 24. So the remaining quadratic now needs to be factored. So I'm going to keep my factor of 6 that I factored out. And let's see, factors of 24 that would add up to negative 5 is what I have to think of. So that's going to be v minus 8 times v plus 3. So here's a very, very important thing to know about excluded values. Before you can actually simplify, you need to make sure you get the excluded values from your denominator. So according to this, I know that my denominator cannot be equal to 0. So that means either this factor here or this factor cannot be equal to 0, which means that I can say that v minus 8 cannot be equal to 0 and v plus 3 cannot equal to 0. Now, a lot of students might worry about what happens to this 6 here. Well, a 6 can't turn into a 0 without a variable, so you don't have to worry about the constant that's out there. So now let's just finish what we have in front of us here. We have our excluded values. Now we can simplify our rational expression. So I'm going to cancel out those common terms, v minus 8, common factors, and let's see what we have left. So in my numerator, all I'm going to have left is just 1 times v minus 5. Now, we're going to want to leave our numerator and denominators in expanded form, which means we don't want to leave it in factored form. So my denominator is, what's left here is 6 times v plus 3, which means that our denominator, once we actually multiply these two together, is going to look like 6v plus 18. So this is our simplified expression, v minus 5 over 6v plus 18. But we must also include a warning about our excluded values. So we'll write where v cannot equal to negative 3 or positive 8. All right, here's our next example. 4w squared minus 36 over w squared minus 10w plus 21. Once again, we're going to have to factor. It's going to be a theme that we're going to see in all these problems. So let's start with our numerator. So our numerator is actually going to have a little bit of work because first we have a greatest common factor between 4 and 36 that can be factored out. So I'll factor that out here. That's going to be 4 times w squared minus 9. Now, w squared minus 9, for those of you guys in the know, is a difference of two squares. So it can be factored using that rule. So it's going to look like this. 4 times w plus 3 times w minus 3. Okay, don't forget our rule for the difference of two squares. If I have a squared minus b squared, it factors to a plus b times a minus b. All right, so we have our numerator, 4 times w plus 3 times w minus 3. Now let's factor a denominator. Our denominator is a pretty simple factoring. The factors of 21 that would add up to -10 are going to look like this. So we're going to have w minus 7 times w minus 3. So again, before we simplify, we need to list our excluded values. So at this point, we know that w cannot equal to positive 7, or it would make w minus 7 equal to 0. And w cannot equal to positive 3, or we'd get this factor equal to 0. So now that we've listed our excluded values, we can go ahead and simplify. I have w minus 3 divided by w minus 3, which will cancel out to 1, leaving us with the expression 4w plus 12, don't forget that we're distributing our 4, over w minus 7. First, we have to list our excluded values, where w cannot equal to 3 or 7. All right, now let's move on to a really interesting example in example number 3. Now, at first glance, this rational expression 4 minus 3v over 3v minus 4, well, a student who has some misconceptions might think, well, I can cancel out the 4's and I can cancel out the 3v's. But remember, you cannot cancel out terms, only common factors. So now we can look at this as 4 minus 3v over 3v minus 4. Now, since these two terms are not exactly the same, you cannot simplify them. However, you might notice something strange going on. In our numerator, I have a positive 4 and a negative 3v. In my denominator, though, I have a positive 3v and a negative 4. They're almost exactly the same factor, except they seem to be switched not only in order but also in sign. This should be a really clear sign that what we need to do is factor out a negative. So you can do this with either the numerator or the denominator. I prefer to choose the numerator just because it allows me to just remember, always change the numerator. So I'm going to try factoring out a -1 from my numerator. Now, what will that look like? Well, if I factor out a -1 from my numerator, I have to change the signs of both terms inside. So it would become a -4 plus 3v over 3v minus 4. Now, I'm going to do a little algebra trick that lets me rearrange these two terms. So it's going to look like -1 times 3v minus 4 over 3v minus 4. Now, we have two factors in our numerator and our denominator that look exactly the same. So they can be canceled out. Now, what's going to be left over is going to be -1 over +1, because that's all that's left here. So we're left with -1 as our solution. Now, before we say that this problem is solved, we also have to find our excluded values, which you should always do before canceling out your term in the denominator. So I know that 3v minus 4 cannot equal to 0. So if I add 4 and divide by 3, I can find out that v cannot be equal to +4 thirds. So in example number 4, we have a monomial 6x squared over this binomial of fourth degree 12x to the fourth minus 9x cubed. So let's factor. Now our numerator is a monomial, so you can't really do anything to factor a monomial, so we're going to just keep it as 6x squared. Now in our denominator, I notice that 12 and 9 have a common factor of 3, and x to the fourth and x cubed have a common factor of x cubed. So if I factor out that greatest common factor, I'm going to have 4x minus 3 left over. Now, if you notice, we don't have any exact terms that we can cancel out, exact factors. However, we do have some factors in common. Now before canceling out any factors, what I want to do is make sure I write down my excluded values. So I know that 3x cubed cannot equal to 0, and then I know that 4x minus 3 cannot equal to 0. Let's solve the linear example first. So add 3 divided by 4, x cannot be equal to positive 3/4. Now our 3x cubed cannot be equal to 0, so I can divide both sides by 3. 0 divided by 3, of course, is going to just leave me with 0. And the only thing that is raised to the third power that would give you 0 is 0. So we can also take what's called the cube root of both sides to solve it. And so we end up with x cannot be equal to 0. The cube root of 0, just like a square root, is 0. So now we just have to finish simplifying. So if you notice, 6x squared, well, 6x squared can be thought of as 3 times x times x. And, 2 times 3 times x times x. Our denominator, 3x cubed, has a factor that can be thought of as 3 times x times x times x. So what we can do here is we can simplify by canceling out a 3 and 2 x's, leaving us with just a 2 in our numerator and just an x times this factor in our denominator, which will end up looking like 4x squared minus 3x after you distribute. Of course, we also need to mention that x cannot be equal to 0 or positive 3/4. Our fifth example is going to be a little more challenging. So let's start with our numerator. Now, whenever we factor and we have a negative leading coefficient, I usually like to factor out that leading coefficient as well as any other greatest common factor. So for my numerator, my greatest common factor between the three terms is -2, which will leave the other factor to look like 4w squared minus 4w plus 1. The signs all changed because we factored out the negative. In my denominator, I can factor out a positive 2 from all three, which will leave us with 16w squared minus 2w minus 3. So now we have to factor both the numerator and the denominator a little bit further, which is a little bit more challenging, like I said. So let's start with the numerator. So I know I don't need the constant, so I'm just going to focus on 4w squared minus 4w plus 1. So because my a in this quadratic is not equal to 1, I need to rely on factoring by grouping. So I know that I have my a times c up here on top, which is going to be 4 times 1, which is 4. And my b value is -4. So I need to find factors of 4 that would add up to -4. That's pretty simple. That's -2 and +2. So I'm going to go ahead and factor that like this. So I'm going to go ahead and use both of these, give them w's, and replace my -4w with this. 4w squared minus 2w minus 2w, that would add up to -4w, plus 1. Now I'm going to factor by grouping. The GCF, greatest common factor of my first side, is 2w, and I'll be left with 2w minus 1. My second half starts off with a negative, so I'm going to factor out a negative, and that's all that these two terms have in common. So I'll just factor out the negative, which means these two are going to change signs to w minus 1. So now since these two terms are the same, I'm going to factor that out, leaving me with 2w minus 1 times, well, what's left over, 2w, and then minus, of course, this is a 1. So my numerator is going to factor to this. -2 times 2w minus 1 squared. Now let's get our denominator factored as well. And change color here for a denominator. So our denominator is going to look like this. 16w to the second power minus 2w minus 3. So again, I'm going to make my x here. I know that a times c goes up on top, which in this case is going to be 16 times negative 3, which is negative 48. And our b value this time is negative 2. So we have to try to think of two factors of negative 48 that would also add up to negative 2. And those two numbers are going to be negative 8 and positive 6. So I'm going to go ahead and use those two numbers as the replacement for negative 2w. So I have here 16w squared minus 8w plus 6w minus 3. I'm going to use factoring by grouping again. Let me separate the top one here. And I will go ahead and factor out an 8w from the first half, which leaves me with 2w minus 1. And I will factor out a 3 from the second half, which would leave me with 2w minus 1. Factoring out the 2w minus 1 will give me this, 2w minus 1 times 8w plus 3. We can't forget the original 2 that came with it. So there we go, we have factored our denominator. So now we can write our newly factored rational expression as negative 2 times 2w minus 1 squared, because there were two of those, over 2 times 2w minus 1 times 8w plus 3. Now, before we simplify this, we have to remember to find our excluded values. So I know that 2w minus 1 cannot equal to 0, which means that w cannot equal to positive 1/2. And I also know that 8w plus 3 cannot equal to 0, which means that w cannot equal to negative 3/8. Now let's see what we can simplify here. First thing that I notice is that I have a 2 divided by 2, which can be canceled out and simplified. And I also have 2w minus 1 squared, two of them, and here I have 2w minus 1. So I'm going to cancel one of those out from both the top and the bottom, meaning that my numerator is still going to have a 2w minus 1 in it, and my denominator, now that we've canceled out the 2, is just going to look like 8w plus 3. Of course, we have to warn people about our excluded values, so we can say w cannot equal to negative 3/8 or positive 1/2. Our sixth example is involving some polynomials of higher degrees that must be factored first. So in this example, we're looking at n to the fourth plus 8n squared plus 7. Degree 4 polynomial, but it's actually a hidden quadratic. Since the degree of the polynomial is twice the middle term of our trinomial here, I know that this is really a secret quadratic. Since our a value is equal to 1, it's very simple. I just have to figure out what factors of 7 would add up to 8. Those would be 7 and 1. So instead of having the factors n plus 7 times n plus 1, since this is a degree 4 polynomial with degree 2 in the middle, these are actually going to be n squared plus 7 and n squared plus 1. Now, our denominator is going to also be a pretty simple factoring job. In this case, I can just factor out a greatest common factor of 3n, meaning that my denominator will end up being factored as 3n times n to the fourth minus 1. Of course, n to the fourth minus 1 is a difference of squareds. It's like n squared minus 1. N squared squared, excuse me. So I can continue to factor the denominator to 3n times n squared minus 1 times n squared plus 1. Of course, n squared minus 1 is another difference of squares, So in the end, our denominator finally factors to 3n times n plus 1 times n minus 1 times our original n squared plus 1. Now, let's go ahead and write our new factored expression here, which is excuse me, going to look like n squared plus 7 times n squared plus 1 over 3n times n plus 1 times n minus 1 times n squared plus 1. Okay, now that it's fully factored, we can write our excluded values, so I know that 3n cannot equal to 0, so n cannot equal to 0. I know that n plus 1 cannot equal to 0, so n cannot be negative 1. I know that n minus 1 can't be 0, so n cannot equal to positive 1. And I know that n squared plus 1 cannot be equal to 0. So if I subtract the 1, n squared cannot be equal to negative 1, which means n cannot be equal to the square root of negative 1, which is I. But since I is an imaginary number, we don't have to worry about this last term. So here we have our excluded values. N equals 0, n is not equal to 1, n is not equal to negative 1. Now let's go ahead and simplify our expression. So n squared plus 1 cancels out n squared plus 1. And so now I can write my rational expression as n squared plus 7 over, now we need to write this in expanded form, so n plus 1 times n minus 1 gives you n squared minus 1. If I multiply that by 3n, I end up with 3n cubed minus 3n. Of course, where we must say that n cannot equal to negative 1, 0, or positive 1. Example number 7 is going to be another challenging problem. Let's start by factoring the numerator. So the numerator has an a value of 3, so I know I'm going to have to use my x and do some factoring by grouping. So here I have my a times c is 12, and I have to find factors of 12 that add up to negative 13. Meaning that I'm going to use factors of negative 12 and negative 1. So factoring by grouping, I'll be able to do this. 3t squared minus 12t minus 1t plus 4. I'll go ahead and factor out the left side first. That's a 3t, and we'd be left with t minus 4. Factoring out a negative 1 from the right side, minus 1 times t minus 4. Factoring out the t minus 4s gives me my two factors, t minus 4 times 3t minus 1. So here I have my numerator. Now to factor the denominator. So for the denominator, I will go ahead and first factor out a greatest common factor. All three terms have a t squared in common, which would leave me with t squared minus 2t minus 8. Of course, this is a pretty simple factoring that we can do. So I'll bring down my t squared. I will go ahead and factor t squared minus 2t minus 8 to t minus 4 times t plus 2. Negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. So here's my denominator. Now I will go ahead and rewrite my expression as t minus 4 times 3t minus 1 over t squared times t minus 4 times t plus 2. Again, make sure you write down your excluded values before simplifying. So we get t cannot equal to 0, positive 4, or negative 2. We can go ahead and simplify. Our t minus 4s can cancel, leaving us with 3t minus 1 over t squared times t plus 2 is going to be t cubed plus 2t squared, where t cannot equal to -2, 0, or 4. Today's final example will have us simplifying a rational expression that's using two variables. Luckily for us, it's not really any harder than simplifying with one variable. So let's investigate just a little bit. So let's start off by factoring our numerator. Now, in my numerator, I can see that 5 is a common factor between all three terms. So I'm going to factor out a 5 for my numerator. And I will have left k squared plus 4kg plus 4g squared. Now, factoring a two variable expression is just like factoring a one variable expression. I know that since my a value is equal to 1, I really just have to think of factors of 4 that add up to 4. So what I'm going to end up with is going to be k plus 2 times k plus 2. Now, because I have another variable in here, I'm just going to add a g to both of these. So we get k plus 2g times k plus 2g times the original 5 that we factored out. So here we have our numerator. Our denominator is a simple factoring. Once again, I just have to think of factors of -6 that add up to -1, which is going to give me k minus 3g times k plus 2g. So I'm going to go ahead and write that in my denominator. K minus 3g times k plus 2g. So when working with a two variable expression, you don't really have to find excluded values since this is not really a normal two variable function. So in this case, and in this case only, we can say don't worry about excluded values. Let's just simplify our expression. So here I can cancel out the terms k plus 2g from both the numerator and denominator, leaving me with finally our simplified rational expression, 5k plus 10g over k minus 3g. And there we have it, guys. Until next time, this has been Mr. Padilla. See you all